a bunch of things going on. Um, I don't know. Maybe you should go and I should share my screen and
Oh,
sort of.
one other fun one for folks to check out. I corresponded with Bob about this. There's a guy out there who tried to do a little implementation of APL in Forth, with his goal being that he wanted to do just the subset that could do the game of life, which is it's sort of fascinating to see, how, and he used a Forth that was able to use Unicode characters, and so it's fascinating to see how few lines in some sense it takes.
uh, one of the things is I definitely I look forward to having Unicode because I think go and make your symbols. But I'll also comment, to me, one of the great liberations from the APL world, space be your fundamental, your space is the prime delimiter. Um, and to go and be able to make words that are somewhat evocative, and one of the aspects of CoSy is you don't like something I've done, it's open. Go and if yours is better than, I mean, there's definitely some vocabulary that needs to be cleaned up. And also, one of the things, the reason why there are these I's and such and such F and such I is essentially just that I had to get the vocabularies made that dealt with integers and dealt with floats, and the knowing how to go and genericize those operations is essentially known. And this is a task which is worthwhile to go and do, but everything should be just simply generic, which it is at the nested, you say boxed, nested list level. But yeah, it isn't that I want those I. Hey, to me, actually, the big nut to crack is how in the hell do you do memory management? And that's what I literally got. A good hint of it was literally waiting for an elevator with Arthur Whitney at Union Bank of Switzerland when he had given a talk on K, the early versions of K. And but that's the nut to go and make this transition from the fixed array, fixed address space that you're working with, a single address space in Forth, to essentially dynamic arrays. Um,
I'm curious, Bob. In terms of the as I dug through CoSy's implementation, like as you say, a lot of those suffixes and so on are an implementation artifact. Do you have a sense of like how comprehensively you've kind of gotten it right in terms of the all the different compositions and the edge cases and so on between the types and
oh well, I don't do. I mean, actually, one of the things, one of the few the few scans and so forth. Oh, um, like plus slash and so forth. I mean, there you can see actually if I can go and show those words. Um, yeah, let me go and share. Boy, come on. Oh, they've changed. Oh, they've moved some things around. Yeah, here are my notes. I never heard of Video Brain, by the way.
it's
The
pretty obscure. It appears that they did not sell a lot of the devices in the first place, and then on top of that, APL was available only as a cartridge, and very few people bought the cartridge. So
yeah,
there's not even pictures of there's not even a PDF of the manual for this APL-S. The other thing is apparently whatever this APL implementation was, it did not have the full APL character set. It had some narrow subset.
Yeah, that other computer, that MCM, which was out of Canada actually, and was mainly used for accounting, I think. I remember seeing them at some trade show or whatever. But another thing you didn't mention actually is that one of the very first um, desktop computers was the IBM 5100 and 5110. And the 5110 had, I think it had the switch, you could go from basic to APL. It actually had APL in it in what was essentially and there was an actual desktop machine. So it's a major one of those aspects. Yeah, I mentioned Bacchus. Oh, I'll get around to this atomic apply is sort of the essence of what makes um, applies things to entire trees. And it's one of those. It's a recursive function, but these functions are actually rather small. And actually, with respect to memory safety, one of the aspects of CoSy is that it's the all the addressing is modulo. So essentially, no index can ever escape an array. So it does, in a very real sense, have
I,
you
actually,
know
Bob, I was going to ask about that. Is that a cozyism, or is that is a thing that K does as well? The
no,
modulo indexing.
no. CoSy eliminates a lot of errors, a lot of, like you get index errors, you get rank errors and so forth. They simply don't exist in CoSy because it will always map. And actually a simple illustration of that, I think I may, oh, I've been engaged in a lot of various interactions with APL groups and the British APL Association just last week. But one thing, a point actually I like to point out, and this is because this is where you have essentially the interface between the fourth level and the larger array level. And there's a sense in which you can look at this as the generalization of a counted string. But the thing is that essentially the first cell tells the type, which says, okay, and so this is just a fetch, goes and tells you essentially what vocabulary applies to whatever this piece of data is. And this is the thing that in a sense is like a counted string. Here, you know how many of these items you have. So that allows you to go and, if you will, factor looping into words. And that's the great transformation that makes it so. I mean, these languages are, of course, not loopless. It's just that the loops are in this vocabulary of things like across and scan and so forth. And reference count is the key to going and returning. And actually, let me go, and I think everybody knows by now that got the F1, of course, gives the answers, and one of the few. Oh, I gotta go, and I've updated this to be F8 to go. But I've recently gone and sort of CoSy's a lot simpler than other than traditional APL. One, it's just pre RPN, um, and it's and here you get the fourth. The word is just a non-blank string of characters. That's so brilliant because you're no longer limited in what your evocative names can be. Oh, and incidentally, by the way, the little log symbol, that literally was done because of its pun. with the tip of a log, with little star with a circle over it in APL. Oh, and I've got some links to, there's a great YouTube that's got a bunch of the people originally involved in creating APL. And about the one of them that I didn't know, Phil Abrams, actually goes into about how the serendipity between the creation of the pipe of the type ball at IBM and the creation of APL was sort of a factor in them coming up with this notion of overstrikes and so forth to go and make a big thing, which was not possible with a traditional typewriter, obviously. Um, and words, this is essentially, all of this is just forth. Words pass words to each other by pushing them out or taking them off the stack. And syntax is RPM. So you see, all I'm doing, this is just talking about forth, and then this
Bob,
is
I had a question actually with the so if you had your how much of the I'm try to say this the right way. You kind of have this interaction where CoSy has, because it's a it's a vocabulary sitting on top of forth. You end up having to sort of deal with the reference counting explicitly in certain places. You'll have do plus and so on. Is that a thing that in ideally you would not have? Like ideally the fourth stack would just be implicitly reference counted and sort of the whole thing would be type safe and so on, or is that or memory safe rather, or
I think that to at some point for ordinary human beings, you want to have a vocabulary that where the raw fourth level is sealed off, if you will, because essentially, and this is one of those things. Let me go over to my I got
yeah,
workspace.
I kind of wondered that. Like it almost felt like you were. Yeah, I see. So you in a perfect world that would sort of be, yeah, the fourth level kind of sealed off is. But I guess a thing I wondered about that is, does that mean you're sort of just trying to do APL on top of fourth, or are you? Is there a place where fourth peeks through? Beyond the sort of as an implementation language.
Of course, I started learning APL, and then when this split came, and Arthur went in the direction of simplicity and transparency in the structure, and but still actually I think too complex a syntax. But he went to lists of lists, and I can go into that. But one of the things is, can you see actually over here, to go and see the definition of any word? Well, question mark, question mark. I was going to go through all the dictionary, but here's what here's essentially the dupe at the if you will, the array level. And the thing is, and it also actually is a see now a lot of stuff that I write, that it's a lot of CoSy that I write gets simpler and simpler. Um, but um, that's one of them. Yeah, I wanted to the all the complexity of APL, and it's gotten far more complex. You talked about essentially what was APL as of perhaps 2020. It now has gotten. You showed Aaron Hughes parser for APL, and he gave a talk at the Lambda conference that I also gave a talk at, and he showed that it shouldn't take the whole page of APL to go and describe the parsing of APL of the language. That's just, and I've commented to him and others is going to RP. I simply I don't do it, I don't do it. There's nothing to do. But actually to go and get at infix notation, which is useful, and obviously it's evolved over hundreds of years. And at APL conferences, there used to be, particularly a guy named McIntyre, who was a great geologist and a speaker, but he would talk about like the history of the plus sign, you know, how the plus sign evolved. And this whole thing of notation as a tool of thought is very real. I mean, it's just impossible to imagine understanding well, quantum physics without the notation. And some of it I like and some of it I don't. I'm not a particular fan of Dirac delta notation, bracket notation. Um, Let me stick to just
Yeah, no,
essentially a,
it certainly made me, a thing this preparing for the thing got me wondering was like, thinking back to when RPN calculators were more common with engineers, you had this moment in time where RPN was intuitive to a lot of folks, and then it sort of went in and out. And that's kind of, and I don't know whether that, there are things with RPN that actually have different intuition versus infix, but I'm not sure. Like we landed on infix in math after millennia of an evolution, but it's also not clear like what the is that helping or hurting or
no, no. I think that the thing infix is the. I mean, I think visual simplicity is extremely important. And infix gives you the advantage that the verb, I'll use, and Iverson in later words, just instead of talking about functions and operators and data and so forth, it'd be nouns and verbs and adverbs, operators or adverbs. Um, and I kind of like this, as a matter of fact, here, I'm saying here, the syntax is noun, noun, verb, AKRPN, reverse Polish. Um, and a noun, I just define a noun as a word which takes nothing off the stack, just puts something on it, okay? And a verb is a word which either does some operation without touching the stack, and go and whatever, change state or go and maybe whatever, or it takes one or more items from the stack and generally returns a result to it. If it takes one item off, it's monadic. If it takes two off, it's dyadic, and in general, result returning. But note a verb, and this is an important aspect, that a verb can look forward in the sentence that it's in. And in fact, actually, I mean, that's the quote, which is just absolutely brilliant, because that's what enables what would in APL be called operators. And in fact, all of the complexity of APL is essentially handled by just being able to go and say, return the address of the next word as opposed to execute it. So even if it's a verb. So, and then essentially, and people have seen me do this a lot, is if I just, I mean, one of the things is you asked in email sort of what the goal of CoSy was, and it's really just to be my notebook. And there's a link to when you talked about diaries and notebooks. There's a page on CoSy, Captain Picard's log, and that sort of is. I mean, Captain Picard would go off and deal with intellectual stuff, but also this is his log. This is and that's why CoSy more than anything else is here. In the first things when you pull up CoSy, the first example is here. Make yourself some calendar, and I'll put down the timestamp. And whenever you have it do a timestamp, it saves everything, before putting down the timestamp. So you have a saved log. So one of my problems, more than anything else, is that I end up having a mess. but but I can go back, to it. But then, yeah, null nouns are lists and so forth, and I go through that. Indexing is modulo, and that again, I find that provides what in APL is called scalar extension, because you have this notion of various discrete numbers of dimensions, and if you have a single number at zero dimension, it's got an exception for zero dimensional things, that it will go and extend. It will map that to the entire array, so you can say one plus an array. But I think I may have an example down here, because that gets into the no, I can insert one. This and mess up my notes here. But you can do something. And by the way, it's because of not having this generalization and the fact that numbers still, this is executing directly in CoSy. But if I do something like 1 minus 1, so I have to do the parens and the i's versus f's and so forth. But with a little bit of investment, which I got conversations going on that. This can be simplified down to essentially being equivalent to APL, not having this sort of nodes. But if I have this plus, well, let me do 10, whoops, and that's on the x86 stack. So I got to turn it into the underbar thing like iota, which, by the way, when I first learned APL, I thought this is so damn bizarre. There's nothing for there's nothing. I expected to be able to see, okay, how do I get an identity matrix? And there's no identity matrix in this language, which is all about matrices. But there's this iota, which just gives you back the number of numbers, yeah, I think I don't believe that K, amazing how much I've forgotten about K. But I don't believe that it has, that I think its indexing is all from zero. And I mean, one of the ways I put it is one of the conundrums of life is that the first number is zero. In address space, you got to deal with it. You need, and I don't know whether I have, but in any case, notice what this did. It added one to the first one. Oh, yeah, I didn't do the plus. So actually, I have sitting here, you can't see it, but down here at the bottom of the screen is the stat. And so I've got that 1 minus 1 sitting on the stat. But I meant to do a plus F6 that. Add one to the first one, subtract one from the second, add one to the third, and so forth. So there are, well, one of the things, it's eliminated an error. I mean, and the other thing is that I mean, there are a good number of cases where that sort of repetition of things can be quite useful. But one of the things also, it makes, you just cannot write something that gets out of bounds. And then, of course, here's we're here. I mean, this is executing directly in forth. And by the way, the fact that Ron chose to have be case sensitive is one of the reasons why I liked it. That and the fact that it had a vertical bar as a comment symbol. And then, of course, there's an extensive vocabulary evolved from the APL and K. And one of the things, actually, and this is something that I realize is more and more, and goes way back, the fact that this entire environment is written is fundamentally written in CoSy. Because the point is, point is to, and this gets back to, I think, the original purposes of Iverson's, purposes in APL as a tool of thought, was to be able to sit there and work through problems and so forth at a high level. But then it was so damned useful in doing, like you say. I mean, you mentioned finance and insurance. I mean, there's a great odd book from the guys at Carnegie Mellon on accounting structured in APL, and I think that's the name of it. But it goes into all you can write these fundamental actuarial algorithms in a line of APL. So I mean, one of the purchasers of the original PC CoSy back in the 80s was Gary Venter, who was, and I think still is, one of the top actuaries, in the country, because he was using APL. He's one of the rare ones who was already doing APL. But that's where a major, major use of it is. And it makes a real difference. I mean, if you're trying to understand something, being able to, I mean, you look at a math textbook, and it gets down to expressing the ideas in hopefully single line equations. And so that's the whole point, the succinctness. And actually, I I had trouble with summation signs where you have to go and be explicit. And this is essentially the way loops are. You got to say, here's the beginning and here's the end and so forth. If you have count included in the data structure, then okay, it knows. And so you can eliminate all of that noise, that visual noise from the expression. And yeah, it was literally only when I learned matrix algebra, A times B, as opposed to summation, all of that. I mean, that I could go and yeah, a lot of history there. But I mean, from there on, actually, the thing is that to be able to have this math in my fingertips, if you will, and be able to go and so now, I mean, I look forward to somebody having motivation to go and implement the basic algorithms for artificial intelligence, because they are all matrix operations or array operations. Um, anyway, I'm this anyway, this is the thing, is this replaces what, if you go and look, Morten Kronberg, who now runs Dialogue APL, which is the great traditional APL. I've been interacting with them, a lot of people on various things. Why is it having trouble finding that site? Did I mistype it? No, what in the world has it done? That's something really weird. I just made a, whoops. Let me erase that. I must have typed, no. It looks like a decent. Yeah, here we go. Yeah, Morton now runs, they always come up with these stupid ads with the ads. But anyway, he's going and yeah, skip. There's more. This is dialogue.
So I see, a wonderful breath of fresh air, this first
Oh,
presentation.
that's Morton.
I can see I have a
But
new,
he goes in, they're getting more and more complex because they're confounding, because they start with this thing and they're making operators that do all sorts of stuff, which are combinators. I've been looking at his example actually
Well,
In
so Bob, that's actually, yeah, I noticed that within their community that they're really kind of going in on the combinators, and it's kind of mirroring things that you might do in Haskell or so on. But I think really what they're trying to do is have it be so that you can have a an expression that you would have maybe done with like curly braces and alpha and omega collapsed into just a sequence that you can just see visually. And it made me kind of wonder, like, Forth already has that because of RPN. You have that property that
right.
you can have an expression that you can substitute in directly without having to worry about what order it's applied.
With the British APL Association last Thursday, as a matter of fact, which unfortunately does not have a Brad Nelson to upload it records the sessions, but it doesn't never uploads them, which is kind of useless. But Morton gave two demos, and one of them was in CoSy. It's just this, and incidentally, one of the things that this needs to be generalized, as a matter of fact, and I think, but braces actually goes and causes this it creates this expression and executes it right in line. So in any case, I won't go through what that does, but there was this whole discussion, and I've looked at these things about combinators and so forth, and also this Conor Hoekstra with code report. I watched this whole thing. He's got a whole thing on combinators that he gave a talk at a functional language conference. And I've been looking at these functional languages, and they again, it just makes things more complex than it goes and yeah, one of his examples was this, and Conor Hoekstra, and watch these. Uh, he's got tons of uh, YouTube's. Come on, I wish. Um, boy, I wish.
Welcome to a Code Report Solution video where we are going to introduce a brand new programming language that is super cool, and odds are you have never heard of it. It's called Wiwa, spelt UIUA, and it is a array language and a stack language. Pretty awesome.
Yeah. I threw his example here, but this I wanted to go and mention. This guy he clearly comes from the APL world, but this Wiwa he's got stacks and arrays and stacks. But one of the things is, again, this just simple brilliance of having space to limiting your words. So I mean, a problem with APL, or in particularly it gets there in J and so forth, is the computer knows how to parse things. It's got an advantage over the human looking at it, because the human doesn't know parsing rules. And so it becomes far more confusing, and making space just explodes the universe of possible of meaningful names. Yeah, what I wanted to get into actually, but I think we've gone on perhaps, Don Golding asked this question about how you learn a big language, because the whole point, if you're going to go and do things on where you just want to have a vocabulary that simply does the things you want, it's got to be a big vocabulary, and that's one of the aspects of CoSy. You look at all these other languages, and they're for programmers. I just want I just want to be able to have a language to go and sit and do things. But in any case, I'd recommend the thing with the combinators is that here are these two. This is a more complex function. This is rather interesting. This I said was dupe. And one of the things is a big example, and it's this colon with overstruck on a tilde is when it's monadic. When it's just got one thing, it actually is dupe. And if it's dyadic, then it is swap. And this is one of the things is in APL, you go and you look at it and you just imagine the amount of code that is required to go and do all the parsing and all of this to go. But I pointed out, and this is something that I pointed out to the British APL Association. You get, this is a rather complicated line, okay. And this is another advantage. RPN has got the real advantage of being able to go and split the lines. So that, as you pointed out, is a list of strings of words, of blank limited strings. And it's very useful, but these two functions here, which are just strings themselves, the first one goes and it looks up in all the dictionaries, all the scripts. It looks for the definitions, the colon definitions of these things, and C, which is something that blows the mind of APLers, that you can C goes and returns the actual x86. So it's got these two strings here, and then it's executing this function here, which is evaluating each of the right arguments on each of the left arguments. And so here we have it found the definition of dot plus in the script CoSy.f, and it's just like showing dupe. But to go and show that dupe is actually, that's more complicated than this is because it's a dupe with the reference counting. So it's three words to go and handle the reference counting, and the $, which I find this is one of those cases where the brevity really makes things simpler. I mean, it gets swapped down to one character, but that's found and that's down at the if you will, the pre-CoSy level, and swaps just 3 instructions. And you go and you consider what APL has to go through to do this. And there's no advantage in brevity and so forth. These combinators, other than the most fundamental ones like okay, taking one argument and applying a function to it, or the Y combinator, which takes 2 arguments and applies them. It's trivial to go and say you want it to operate on both, the same number on both the left and the right. Dupe it. You want to commute which of the 2 operators and do them in the reverse order. Well, that's swap, and you're looking at just 2-3 machine instructions to get that done. So yeah, I looking at a bunch of these things on combinators, boy, was I underwhelmed by them.
I mean, there is a whole line of thought with combinators where one of the properties you can get out of them is that you can have them be lazily executed and things like that. And so there is kind of there is a class of things that you could in principle do, but yeah, I'm not sure that it feels a little bit like, especially with APL, they're kind of working around it being because the array languages have the should I say this the right way? They don't have the things are not first order in them, so then you end up having to kind of work around that, and I think that's where the combinators show up, is because they're
this whole notion, and this is one of the things, another one of these new array languages, or the APL derived languages that Conor Hoekstra.
BQN, is that the one?
Right, but I mean, this is the thing that again, all of this is handled by just having the quote and returning the address of the next word, whatever the hell it may be. That makes your functions first order. I mean, and for that, I mean, just the simplicity of Forth to do these things cuts through so many layers of complexity again, well, you see it even in this. I'm actually going and here I've got the tick goes eval expects CoSy arguments and returns a CoSy list. And incidentally, the outer product, and this is directly Arthur Whitney's, you're having each right and each left. Because an outer product is essentially going and applying, holding this constant and doing it on each of the others. So that's in each right or each left. They'll go and produce the transpose of each other. And actually, because it's RPN, there's also each monadic means, okay, I've got one, it's just the top of stack. It's operating on whatever's on the top of stack. And each D says do it pairwise between these two arrays. I don't know, we seem to be down to just a small subset of the group that started. So perhaps we ought to call it off, but one thing I'll say, I need a Leo Brody too, and you've done actually some yeoman's work in going and giving a whole lot of the whole background of this. But again, one of the things is, I mean, you've I'm sure noticed that the market for K is big data. And now they really got to push on AI applications and so forth because they got vector database. Well, the data structures in CoSy are isomorphic with those in K, pretty much. So while that's there's a significant distance between I mean, I want this environment where when something comes up, if I can think it, I can do it. And if I need to make some more words to do it, I can make them. And there needs to be a significant winnowing of this. I mean, I've said that, again, it would be great to go and get it running directly in eForth or whatever, at which time you'll get rid of these speed problems. But Max Sun, who actually gets mentioned by Morton, because he's fairly new, but he's actually at the Lambda conference, he gave a talk and he downloaded and got working CoSy. Yeah, in any case, I've said, CoSy will only be clean when it gets transliterated, and a lot of the stuff that's specific to Riva and so forth gets discarded. And also, I mean, CoSy at this point in time, and even this interface sucks. And if there are some widgets in, HTML browser widgets, which give you simply a piece of paper that you can go around and know what and you click it somewhere and it knows what the address is, then you can implement the CoSy and, perhaps, really make it a real thing.
Yeah, that facility of an interactive notebook is sort of I see where you're coming from. That like it's sort of folks will use what is it, Jupyter Notebook to achieve that type of thing, but it's Python and it's a bunch of caveats and so on.
Yeah, one of the interesting links, and just go and maybe finish off with this, where it's go to CoSy, but if you click here and go to this cozy.cozy page. Oh, and did you lift this the comment from Perlis from here?
I don't know if I lifted it from there. No, I think I grabbed it somewhere else. But yeah, you mentioned it before, but I mean, I knew it from, it comes up in
Yeah.
like the Lisp community and so on. It's funny because that quote in the Lisp community is all about it is lists of lists, but like I think an interesting contrast is that the way Lisp still sort of deals with lists of lists, word at a time, in a way, in kind of that von Neumann way.
Arthur has said that has described K as being Lisp with item lists instead of binary lists. So I mean, there is a lot of there's a lot of that flavor, and you're mentioning. I mean, I sort of think that there are only five. I mean, man, I don't understand the distinctions. I've looked at a little of the distinction between Haskell or Scala or whatever. But I just see I lump all languages, including C, under ALGOL. I mean, there's this whole, that whole paradigm, which is essentially a large program paradigm, which most languages are stuck in. That what you're going and doing is you're making a program to go and do some big thing. So you have all sorts of little switches on it and, different things and so forth. And then there's Lisp. There's a second, definitely unique notion. And then there's APL. And then there's fourth. To me, and possibly Smalltalk gets in there as a but those are the ones that actually have fresh ideas. And this is the thing is when I
would agree with that taxonomy. Like it's funny, like ones like Prolog are kind of like there, but they're like, it's a shallow set of ideas. It doesn't like, if you actually watch how anybody programs in Prolog, they basically just use it as Lisp. Like it's Lisp by other means. They don't really use tracking. They don't really.
Back when Prolog there were some at the APL conferences. There's Prolog in APL, and Prolog again has this scalar sort of an attitude, if you will. And the thing is, it's just, okay, I've got a full set of logical operators. And by the way, one of the things I think is just brilliant, and you wonder how in the hell could programming go on so long with just the ASCII keyboard without even having the logical operators, the most fundamental logical operators. It's just crazy that you don't have a full set of logical operators. That alone is a good reason for the APL character set. But in any case, I wanted to. I'm definitely at this stage here in terms of CoSy. Another time when I was concerned about getting credit for some idea I had. Let me move this over because it's covered on my screen. For some idea, Ken said, Arthur, if it's a really good idea, you're going to have to shove it down people's throats. And that's sort of where I feel I am at this point. But one of the things is, there's this comparison with Python, and you see it's major, but I wanted to come down here, and there's too many in the sense I've got too many things. But this is quite interesting. This guy, Peter Wang, who was one of the co-founders of Anaconda and the Jupyter Notebook, sort of, in Python. He gave a talk at a KX conference, at a K conference. And he actually is going on, and I think this goes to the actual timestamp where he does this. But in any case, where he goes, well, let me look and see. He goes on as to, again, these damn things. This is really annoying. it comes with these ads. But he goes on. Yeah.
And that was when I discovered Forth and the world of cat native languages.
Well, this is
Right.
the creator of
and so I decided to just kind of nerd out on that a little bit, right? And what I realized was, okay, if every call is call CC, right, the world changes. If concatenation is fusion, because one of the hardest things about trying to do something like perform in D3 in Python,
I'll leave this, but I mean, I think it's extremely significant, and yeah, it is like a Jupyter notebook, but not for presentation as much as actually working through. Actually going and working through the problems and being able to do it. One word that's very important and AAPLY question mark. This is actually one of the longest pair of words, but what it's doing, and this is the thing is, I mean, fundamentally the structure in CoSy is trees, or even sometimes bushes, but it goes out, and so you have the nested level, which is type 0. So all you got to do is the type 0. Then okay, this is a list of pointers to, more, deeper things. And you get out to homogeneous arrays of whatever type, whether they're floats or ints or characters, and this can be fleshed out with whatever, where you got this vocabulary. But if it's type 0, it just goes out. So, and with modulo indexing, all trees will match another tree and have corresponding leaves. So it gets out to the leaf level, and then it goes and
never have anything that doesn't match in terms of type or rank or whatever. It's sort of, yeah.
Right. Well, the type can, when it gets out there,
type can fail, I guess. Yeah, but rank and
rank and indexing just simply can't. I mean, and that's one of those things where
you're muted, Bob. You're muted.
Pardon?
You're muted. I didn't get that last bit.
Well, generally I have, this meeting, for some reason it came up and you hear me now?
Yeah.
Oh, okay. I don't know what, Zoom did something there.
Yeah. I think I got the gist of it, though. You were saying something about the fact that with the modular indexing that it.
So, I mean, and this at the list level, this again will match the lists to each other, if you will, and actually, I think that this modulo indexing, just going and building modulo indexing into it, is one of my great ideas. If there's anyone.
It is an interesting idea. But Bob, I'm noticing the time is. Do you suppose we could call it on recording? All right. Let me go ahead and pull the plug on the recording. We can. All right. 1 second.